Hello, everyone. Welcome back. Today is our final topic in this unit. It's about spanning sets. Okay, so let's talk about spanning sets. Here it says every vector in blank can be written as a linear combination of the standard unit vectors I and j. So every vector in what? Well, that would be R2, right? Or 2 space. Okay, this is something we learned previously. Which are the vectors? Well, let's see. 1, 0 for I and 0, 1 for j, right? It is said that vectors blank and blank span R2. So 1, 0 and 0, 1 span R2, right? Now, what do we mean by that? What do I mean by they span R2? What I mean by that is that with combinations, with all the different combinations of 1, 0, and 0, 1, we can get any value in R2 we want, okay? I challenge you to give me any number, right? Any x comma y combination, and there's always a way using 1, 0, and 0, 1, right? With a linear combination that I can get to anywhere on the set. So that's what I mean, is that these two unit vectors can span anywhere on R2, right? Another way we can say it is that I comma j is a set of vectors that form a spanning set of R2, right? There is an infinite number of spanning sets for R2, right? 1, 0, and 0, 1 is probably the most obvious one, but there are other ones as well, other combinations that span it, and each must contain a minimum of two vectors, okay? They must contain at least two vectors in order to even have a chance and come close to spanning R2. Here it says, in fact, the only time two vectors do not span R2 is if the two vectors are scalar multiples of each other, or in other words, collinear, right? Because let's think about that. If I have two collinear vectors, well, are they going to span all of R2? Well, no, because they don't give us that second dimension then, right? They're just parallel to one another. And so they wouldn't span the entire thing. So let's do an example here. Here we want to show that this set of vectors, -4, 1, and 2, 3, is a spanning set for R2. So let's do it. So we know that if it is a spanning set, then that means that x comma y is equal to s -4, 1 plus t 2, 3, or we don't have to use s and t, it could be a and b, you could use anything you want. Then there must be a formula for s and t where that we can express in terms of x and y. So in other words, it can't be collinear. We have to show that this is not collinear. There was a previous example we did in the last lesson where we showed something was collinear. In this case, we're trying to show that it's not collinear. So I'm going to give an example of how this is not collinear because it is a spanning set and can span every part of 2 space, as can 1, 0, and 0, 1. So let's do that. Here I have, that x is equal to -4s plus 2t, and y is equal to s plus 3t, right? Now what am I going to do? I'm going to use substitution. I'm going to sub s is equal to, all right, let's see, s is equal to y minus 3t. So I'm going to sub that into the first equation, right? Into equation 1. Okay, so let's do that. So in that case, we would have x is equal to x is equal to what? -4 times y minus 3t plus 2t, which means x is equal to negative 4y plus 12t plus 2t, which means x is equal to negative 4y plus 14t. Good. So what does this tell us about t? Well, this tells us that t is equal to x over 14 plus 2/7 y, right? Now let's sub this back into the second equation. If we sub this back into 2, we would get that y equals s plus 3 of t, which is x over 14, plus 2 over 7 y, right? Which means y is equal to s plus 3x over 14 plus 6 over 7 y, right? So therefore, what is s equal to? Well, s and y can just swap, right? S is equal to, let's see, it would be negative 1/7 y. Or would it? 1 second. Let's make sure that's right. No, sorry, it'd be plus 1/7 y. I knew there was a little something wrong with that. Plus 3x over 14. So basically, in this case, we didn't just get numbers, right? We didn't just get, numbers. We got that s is equal to this and that t is equal to that, right? And so in this case, there's multiple correct, right? So here we've shown that in this case they are not coplanar, right? They don't have that collinear trait, that these can be expressed. These are a spanning set, right? Because in this case we had for s and t just combinations of x and y, as opposed to getting actual numbers for s and t, right? If we go back to the example before, we can see here that we just got numbers, right? We got specific numbers because we got them to be coplanar. But in this case, we don't have that, right? In this case, we got, we got more equations to work with, right? And so because of this, therefore, they are a spanning set, right? Because all we have to do to show something's a spanning set of R2 is we must show that the vectors are scalar multiples of each other, the vectors are not scalar multiples of each other, and we showed that clearly here they are not, right? So they're not collinear in this case. Okay, so now we're going to show that these two do not span R2. So in order to show that, we must show that they are linear combinations of one another. And it's pretty clear how, right? If we look at 4 comma 7, we could argue, oh, well, 2 of 4 comma 7 is the same thing as 8 comma 14. And so therefore, they cannot be, right? These vectors are scalar multiples, so they don't span R2, right? These vectors are scalar multiples. And so therefore, they do not span R2. Very good. And then here's just a kind of an ending statement to finish off with. It says here that we can't use linear combinations of sets of vectors to obtain anything else other than a multiple of vectors. For example, for our example, all vectors created would be in the same or opposite direction of 4 comma 7. We couldn't create vector 1 comma 5, for example, from these vectors, so they don't span R2, right? So basically, they only span linear combinations of 4 comma 7. They don't span other vectors. And then 1 comma 5, this is just, one of many, many, many examples in R2 that cannot be spanned by it. Good. So here I have some practice. Here's some practice problems for you guys to try on your own to figure out what's a linear combination of what and what's a spanning set and things like that. So if you want some more practice, there's some more practice right over here on this page. But that's everything for today. Bye, everyone.